All right, hello there. I'm going to go over the answers to assessment number 2 in Schoology. And remember that these are not in the same order that you have them in your test because they were all mixed around when I give them to you. So anyway, so looking at this question here, name the parts of this picture correctly. So up at the top we have the vertex. Remember, that's like the corner in a way, but it's like the top of the U or the bottom of the U. Like if your parabola is going like this, then it's down here. All right, you got the y-intercept at the bottom here. All right, because that's where you touch the y-axis, and then of course you have the x-intercept right here. And there are 2 x-intercepts, but we only could mark a spot for one, but there is another x-intercept right there. Okay. All right, going on to the second question here. Again, my question 2, but maybe not yours. So I have to factor this expression. So I have 3x squared plus 7x minus 6. Now, since all the answers are displayed, you could actually FOIL them all out, but that's a lot of work, all right, and see which one is the correct answer. But I would start off, there's no GCF, so I'm going to do 3x and x. And what makes 6? I got 6 and 1 or 3 and 2. Now, if I'm going to try 3 and 2, I can't be putting the 3 here because there's already a 3 right there. So I'm going to try the 3 here and the 2 there and just see how it works. And if it doesn't work, then we'll try the 6 and the 1. All right, so I'm getting myself a 9x here and a 2x there. Well, if I do 9 minus 2, that'll get me the 7 in the middle that I want. And if I do a plus here and a minus there, that'll also get me my negative 6 that I want. So there we go, and there is the solution that you should choose up at the top. All right, next one here. So this is f of x equals x squared. So remember, that's just your good old basic parabola, right? So you have a parabola, a nice U shape. It has the points, 0, 0, then 1, 1, then 2, 4, and so forth, and then negative 1, 1, negative 2, 4, and so on. All right, so this is not like absolute value function. There's not like a clear slope on here, but it's a nice curvy shape on that. So let's talk about these transformations. A negative produces a reflection over the x-axis, all right? Then the x minus 4 inside here produces of movement up to the right 4 spots or 4 units. And this plus 1 makes you move up 1. Now it is, why did I write plus? So it is also, you are also able to go in Desmos and graph each of these things, and then you can see what's going on. But basically this new parabola is going to look like this. It's going to move right 4, and it's going to go up 1. So it's going to be right here. It's going to be upside down. But you're going to notice that it has the same shape as the original, so it doesn't stretch or shrink. All right, it just has these 3 things that happen to it. All right, this next one here, complete this statement. So there was a drop-down menu right here, but this was trying to talk about end behavior. It says, as x goes to infinity, the y value of the parabola goes where? And as x goes to negative infinity, where does it go? So what this was intending to imply was this end behavior right here. So this arrow on the right-hand side, x is going to infinity because we're on the right-hand side. So I'm going to put infinity, and my arrow is pointing down in the y-axis or on the y value, so that's negative infinity. And on the left side, I'm going to negative infinity, so that's my x value. My y value is also negative infinity because it's pointing down. So both of these answers should have been negative infinity or negative infinity. I think it was written in words, but however you want to answer it or fix it on your stuff. All right, this one right here. So this was you were asked to do the steps for finding the inverse. So the first thing you do when you find the inverse is you reverse the x and the y. So I should switch the x and the y. I make this x equals 4y plus 12. And then I have to resolve this for y. So I have to take away 12. So I get x minus 12 equals 4y. And then to keep solving for y, I divide everything by 4. So I get y equals, that will be 1/4 x minus 3, right? And those are the steps that I follow. All right, here we have to completely factor this expression. So I'm going to work down here. I notice there is a GCF, so they all divide by 2 and x. So I'm going to pull out a 2x. So that's like I'm dividing everything by 2x, 2x, 2x. So when I do that, I get x squared minus 10x plus 24. And so then I have to keep factoring more because I noticed that now 24, what makes 24? 8 and 3, 6 and 4, 12 and 2, 24 and 1. I also have to make 10 in the middle. Now, you notice that there's a couple things here that would make 10 conceivably, like 12 minus 2 and 6 plus 4. But when I look at my problem, it's a positive 24, so that means my signs here have to be the same, either 2 pluses or 2 minuses. Well, when I look at the negative 10, I know that I better choose 2 negatives. So that means I'm going to have 2 negative numbers then summing up to negative 10. So that would make my choice 6 and 4. Because with 12 and 2, I need opposite signs. So 6 and 4. And so there's all your factors, so you would choose accordingly. All right, here, we wanted the increasing and decreasing intervals, and there's some choices down there as well. Let's just take a look. So the increasing side of this picture is the whole right side. And so if you look at that, the whole right side is increasing, so that begins at the number 0. All right, it begins right here at 0 and goes to infinity. It's the whole right side of this graph. So that green area begun when x was 0, and it went over to infinity. And then the whole left side from 0 back to negative infinity is decreasing. So I would go ahead for my increasing interval. I would say start at 0 and go to infinity. Remember, you always use parentheses. And for decreasing, I would say from negative infinity to 0. I always use parentheses, and I always put the smaller thing on the left and the larger thing on the right. Okay. All right, this guy here, solve by factoring. So when you factor this, it's already in standard form. There's no GCF, so I'm going to start factoring. I put a 2x and an x. All right, and then 5 and 1 are my only choices. So if I put the 5 in the back and the 1 here, notice I have 10 on the outside and 1 in the middle. So all pluses means I get my everything that I want. I get my 11 in the middle and my 5 on the end. So I take these two parts, 2x plus 1, I set it equal to 0. And I take x plus 5 and set it equal to 0. And then I solve that. So I would, on this one, I would take away 1 and divide by 2, so I get negative 1/2. And over here, I would get x equals negative 5 when I take away 5. So you can say that, or you could have written your answer in brackets, negative 1/2, comma, negative 5. All right, and hopefully you write it a little bit nicer than I did. All right, either or. All right, so here we're talking about domain and range. So domain and range involves the width and the height. So the width of your graph, you can also go and label these points. This is on the right side and it's going down. This one right here is a 0.34. And this over here is the point, negative infinity because it's on the left and it's going down also. So if that helps you, then you can go through here and you can say to yourself, oh, domain. Here's the 3 important points on my graph. What's the smallest and what's the largest? So you would look and you'd be like, oh, the smallest is negative infinity, the biggest is positive infinity. Or you can say to yourself, this graph opens up forever. Like every x value, everything on this line has a place on the graph. For instance, 3 is right there. 1 is right here. If I go to 0, it's down here. If I go to 6, it's down here. Now, it might not seem like there's anything over there, but you know, if you go down, this graph is going to come and meet you, and there is going to be something there. Okay? Now the range is the height. So you can look at these y values if you like, or you can think about the height. The highest this goes is 4, and the lowest it goes is down forever. So I have to put that in order. My down forever would be first because it's smaller than 4 on the other side. It is touching 4, so I'd put a bracket. All right, here we go. F of negative 2. So I have to go to this graph, and I have to go to negative 2 right here, and I have to go to where the graph is, and there it is at 4. So that one would be considered 4. F of 1. So same thing, I go to 1, and I go up to the graph, and there it is at 1 also. And F of 0. Well, right at 0, it's at 0. So that's it. I think there's one more, F of 2. So when I'm at 2, now this is my choice, my hard choice. When I'm at 2, do I go here or here? Well, I don't go there because that's a ghost point. I go up here to 3. So it's not really supposed to be there on the open circle. All right, are these inverses of each other? So you have a couple choices here and reasons to explain. So you can look for some points. So when I look at this graph, I see the point negative 4, 0, and I see 0, negative 4. Well, -4, 0, and 0, -4, they're inverses of each other, all right? And you should always find a couple more points, or maybe one more. So how about this one right here? That one is the point 5, 3. So if I look on here, I should see 3, 5, and there it is. So every point on the blue graph, its inverse point is on the red graph. Or you could come through and you could say to yourself, well, I'm going to draw that line that we always drew in class. The line y equals x goes right across the middle here, right diagonal, all right? And this line y equals x, these two graphs, the red and the blue line graphs, are symmetrical over the line y equals x. So you could say that the graphs are symmetrical over the line y equals x as well. So however you want to explain it. All right, couple more. So this one's factoring. This is the difference of perfect squares. So if I break up my x's, and then I need something that multiplies to 36, but I need it to be the same number. So I'm going to use 6 and 6. Well, I want that 6x to go away with this 6x. I want it to cancel out. So I'll make one of them positive, one of them negative. And there I go. It's factored. All right, so if you were told to factor this expression, let's go ahead and do it. So if I factor this, I break up the x's, I would want to know what multiplies to 36, -36, so 9 and 4, 6 and 6, 36 and 1, let's see, there's also 12 and 3. I have to multiply to -36, and at the same time I have to get it to add up or sum to -5. So that's this one right here. So I would want a -9 and a +4. So think about that process and you'll know what answer to choose. All right, I think this is the last one. Yes. All right, why is 3x squared the greatest common factor of this expression? So I got a lot of crazy answers on this problem. All right, so think about the words greatest common factor. All right, so think about what the things that multiply to 6. So if I think of the factors that can make 6, if you try to break it up, you're like, oh, that's 3 times 2. So the factors of 6 are 3 and 2. And then 15. 15 is 5 and 3. All right. So 3 is the number, the greatest number that they have in common. So that's what you say. So 3 is the largest number that is a factor of both 6 and 15. Okay. All right. Then you have to also, some people didn't do the x squared part. All right. So you would say to me that, let's see, x to the third and x squared are my two pieces right here. The greatest number of x's in common is 2. So that means basically x squared, right? So those two reasons are why 3x squared is the GCF. Now you can say I'm a little bit shorter probably or a little bit different way, but those are the main reasons, all right? So let's get that straight, all right?